Hi, I'm the PC Expert Amateur, and we're going to take a look at the theory behind mounting an AIO. Now, obviously, the first thing you have to take into consideration is the water block going to fit the area where your CPU socket is? And the second thing that you want to consider is the radiator going to fit anywhere in your case? And, well, then the third thing would probably be, well, size. But make no mistake, just because it says it's a 120 or a 140 or 240 or a 280 or a 360 or a 420 doesn't mean that's the actual dimensions of the radiator. That could just be the dimensions of the fans. And so you might buy something assuming that the stated number is the actual dimensions, the length and the width of the radiator, when in fact it's not. A lot of times the radiator will be larger than the fans themselves, and then you'll discover, much to your dismay, that the radiator won't fit where you wanted it to go. You also have to look at, and I'm gonna bring out my Be Quiet Pure Loop, not because it's a great AIO, but just because it's light, so I pulled it out. All right, so you also want to look at the length of the tubes, because if you have a large case, say a mid tower or a full tower, you're going to have to make sure, if you want especially to mount it on the side or on the front with the tubes going down to the bottom, then you will need to have an AIO with long tubes. Most AIOs do not have really long tubes. In fact, in order to mount my Thermalright Frozen Knot, in my case, with the tubes down in the front or the side, they were both a problem, because the tubes at over 40 centimeters long were still not long enough to reach that position at the bottom of the case. And that was primarily because the graphics card was in the way. So I actually had to buy a separate vertical mount for the graphics card that sits on the power supply area's cover, or shroud, as people like to call it. So you'll have to consider that. And then on top of all of those factors, and I'm going to step backwards a little bit here, is when you are looking at where it will fit, you have to not only consider the thickness of the fans, which are typically 25 millimeters, but you'll also have to consider the thickness of the radiator. So combined, you may have a fan plus radiator that is, say, 50 millimeters thick. And that means that if you're going to put it on top and there's only 40 millimeters of clearance between the top of inside of your case and where the motherboard is, you probably won't be able to put it there. Not good, right? And it gets more complicated. And then you have to consider, well, let's see, I can only fit this size in there or that size. You know, if you get down to a 120 is just about the least useful purchase you can make as far as a water cooler is concerned. So you might want to think twice about buying a 120 or a 140. A lot of them can be beaten by a decent air cooler, so you would want to do some research if you're really, really interested in it. But honestly, I would say just skip 120 and 140, go to the 240s and the 280s at least, if not the 360s and 420s, to make sure that you're going to have enough power to dissipate the heat that's being produced by your CPU. When I say power, I mean power in terms of the number one, the fan speed, number two, the pump speed, as in how many liters it pushes around and how quickly it moves it around. You'll also want to look at the radiator, how efficient it is at dissipating heat, because that's where the heat gets dissipated. It gets pulled away from your CPU by the water block, which often is where the pump is, and carried through the tubes into the radiator, and the fans blow the heat or the cool air into it so that the heat will be neutralized. It isn't that the heat is exhausted on the other side, it's that the heat is combined with the warmth, and then you need to reach a new temperature. There's no like physical exchange. It's just heat. It's just temperature. So there's a disagreement about whether or not you want a really high speed pump or a lower speed pump. Now, my thought on this is that if you get one with a high speed pump and you don't need it running at, say, 5,500 RPMs, that's okay, because all you've got to do is turn down the pump speed. You can run it at a constant speed so there's not as much wear and tear on it. It could be 70%, and that's fine. If 70% is too loud, you could lower it to whatever you feel is acceptable, but understanding that every time you do anything to make a cooler quieter, you are reducing its ability to cool your device, which is specifically the CPU, which is the central processing unit, or the brains. Now, you can also cool things like storage devices, especially hard drives and SSDs, but that's not very effective at this point in time. You can also cool off a graphics card, but the GPU, or graphics processing unit, which is the brains of the graphics card, doesn't necessarily need that unless you're doing like a lot of AI work or something like that, in which you're just like constantly making it work for hours and hours on end. But normally you don't need it. Plus, it tends to be pretty expensive to get one because a lot of them do not have a mass-produced water block that you can mount on. You're going to have to remove the fans and the shroud and all this other stuff, and then mount a water block on it. It's not impossible. It's not necessarily difficult, but if you feel intimidated by it, that can make you feel it's very difficult. Not that I've ever done it, but I understand that psychologically this can be the biggest barrier, is if you don't feel confident about doing it. So I would say that if you're going to get a water block for your graphics card, make sure that you watch some videos and try to find somebody's broken graphics card that you can experiment on, just so you can get familiar with how to remove everything that you're going to remove. And so make sure it's the same model as the one that you've got, or extremely similar, so that you don't start taking apart your real one, having practiced on the broken one, and you discover, oh, this wasn't on the practice graphics card. What do I do now? So, anyways, the other big concern that I want to address, and this is the main point of this video, is the pump. Pumps can be quiet. Pumps can be noisy. A lot of pumps are made by from a pump design that was patented by a company called Acetec, or Acetec. I'm not really sure how you pronounce it. And I believe the patents are expiring. But nevertheless, there are other companies that make proprietary pumps and sell them to companies that make the water coolers. So there are other kinds. But you're going to find them in three places. So the first and most common place on most AIOs is the water block. And that is, so you're going to mount this directly with it, this part touching the CPU's IHS, which is the top plate that you can see on it. And I'm touching this only because the plastic is on here. Don't put your fingers on it when you remove the plastic, because that plastic is there to protect it from your finger oil, so that the paste, the thermal paste or thermal pad, or whatever it is you're getting, will do an optimal job of cooling off, or transferring the heat from your CPU into this. So then it goes from here into the water. It gets moved by the pump through the tubes into the radiator, and the fans blow on the radiator, causing a temperature change. So the cooled water then returns to the pump head, or a water block. But not all AIOs have their pump in here, like this one does not. Now, if you look closely, you can see where it is, right there. And so this is a nice design as well. There are certain drawbacks to each type of block. I'm not pump, but I'm not an expert. All I can really tell you is this: if it's in here and you don't have it mounted correctly and air starts building up through permeation through the tubes or other methods where liquids are replaced with gases, if it gets trapped up in here, then you can have a problem. If it gets trapped here, you can have a problem. Or the third position for a pump is actually right here, which is not this kind of fan, this kind of AIO. I do have one AIO out of the ones I have that actually has the pump mounted into the radiator. And that's the relatively new AZA Cube 360. And that is right up in this area here is where they've got their pump. Every pump position has drawbacks. So let's take a look. Going back to the pump in the water block, if that's where your pump is, then the problem is you have to be careful to make sure to mount this so the tubes aren't coming in and out of the bottom. Why? Because this effectively becomes a trap for air. As permeation occurs, cavitation and so on, and more air is in this system, it's going to accumulate up here. Now, if there's no pump up here, you're thinking, well, then it doesn't matter. Well, actually it does, because once this gets full enough, the water is no longer fully in contact with the cold plate on here, which is what this is called. The other plate on the top of the CPU is called the hot plate. Kind of makes sense, right? But if the hot plate is transferring heat to the cold plate and the cold plate isn't touching water anymore, or is only partially touching water, that means that the part that's still touching water, say down here, is going to be doing a good job of transferring heat into the water. But all the metal up here above the level of the water is going to be overheating, both from the heat at the bottom that's going into the water and from the heat that's going directly against the cold plate here. So you can end up having poor control of temperatures. So when you mount this, no matter whether the pump's here or not, at the very least, mount it like this so that the tubes are coming out of the side. However, if you can, it's best to mount it with the tubes coming out of the top. This prevents air accumulation in this. Now, one of the worst possible ways to mount an AIO that has the pump in the water block is with it on the bottom, because where's the air going to go? It's going to go up here. Now, if you've somehow managed, and you can see this is not easy to turn it around. If you've somehow managed to mount it so it's like that, well, yeah, you're going to have air in the tubes, and that's going to cause some problems. But if you can't, air is going to get caught in the water block. Whether there's a pump there or not doesn't matter. Same problems occur. If there's a pump in here, then that pump is eventually going to get so hot it's going to die, which, we don't want that to happen because it's bad for your computer. Now, modern computers are designed to shut down when the temperature exceeds a certain limit. First, it'll slow your computer down so that it doesn't in an attempt to prevent overheating. But if it can't succeed by turning down the speed, or the clock speed, I should say, of the processing unit, it's going to shut down the whole computer to protect the whole computer from thermal damage or heat damage. So that's the problem with that. So remember, and this is true of no matter where the pump is located, whether it's here or here also, you always want to have the tubes, as much as it's humanly possible, coming out of the top of the water block, just for maximum efficiency of heat transfer and also to protect the pump if the pump is in here. Now, if you're in a situation where you see how this is positioned like this, where the pump is still the highest point over here in the water block, that's going to produce the same result. You're going to end up with a water block full of air eventually. Now, it depends on the particular model or the particular brand as to how long before air is trapped in large enough quantities in the water block that is going to start causing problems. So, I mean, the worst ones, it can happen with a matter of months. The best ones, you may go 10 years. It's really hard to say. But just do everything you can to avoid having the pump and or the water block be the highest point in the loop, because air goes upwards. Even when it's being pushed around by water, it's still going to tend to accumulate in the water block. So we want to avoid that. Now, if you have a setup where you've got the pump in the water block, you again want to have that water block with the tubes coming out of the top, and ideally you want to have the tubes coming out of the bottom of the radiator. Well, why is that? Number one, air cannot accumulate here. Number two, air that gets into the radiator is going to rise to the top, and it's going to stay there. So it's going to have the least impact as far as keeping your computer cool, keeping your CPU cool, that is. So if you do like this, again, you want to have the tubes coming out of the top, but if you have it like this, what's the problem going to be? Well, if you have the tubes coming out of the top, eventually enough air could accumulate here that it could affect the flow of water into and out of the radiator. So yeah, it could take quite some time for that to happen, but eventually it's going to get noisy. Same thing with here. This is another problem with air bubbles building up or into your system, your loop, because it's going to add noise. You're going to hear gurgling and glubbing and all kinds of weird noises, and you're going to be like, what's going on? And if it happens to be that the air is trapped where the pump is, you're going to hear other less pleasant noises than that. I'd rather hear gurgling, and I can imagine that I'm next to a stream, than to hear grinding noises and screaming noises and stuff like that. So, this is, as long as if the pump's here, that's great, right? Because the air is going to be moving into the radiator. But again, it's less than ideal to have air being trapped up here at the same level where the pipes are going in and out. So what are you going to do? Well, one thing you can do is to mount it like this. So you've got your pump, your tubes coming out of the top of the water block. You've got your tubes going into the bottom of the radiator, and they are going out and in such a way that air will accumulate at the top of the radiator, which means it's going to take a long time before it starts to impede water flow. So this is a really good position, one of the best positions for mounting between that and that. These two are the generally accepted as the best mounting positions, with being on the bottom the worst. Side mounting, which is to say on the right-hand side of your case, on the same side as where the motherboard is mounted. I keep on looking at the video recording instead of looking at you folks. I'm sorry about that. It's your brain just wants to look at a face, so I'm the only face I can see here. So, but what about if you don't have a pump in the water block? What if you have the pump here? Well, same basic problems, right? So if you have your AIO mounted on the bottom, you have to worry about this, making sure that air can't get trapped in there, which is difficult because if it's not in the water block, it could be in the tubes. But, at least it's not going to be in the pump. That's guaranteed because the pump's way down there. And the same is true if the pump is inside of the radiator at this juncture here. You're not going to have to worry about air accumulation very much at all. And even if air does accumulate to the point where it's getting to the tubes, the radiator pump is going to push it out, and it's going to be up here. So, not ideal, and you generally don't get the best temperature results from this position. However, there are cases, especially smaller cases, where it's the only viable option. Now, if you go like this again, and you have everything mounted like this, is the pump going to have a problem? No. Is there potentially going to eventually be a problem for the block? Well, yeah, eventually you could get enough air up in this area here that's going to be an issue, but most of the air is going to be stuck up here, so that's not a big deal. Um, but again, you want to look at what are the possible ways to mount it that are going to cause the least amount of accumulation of air in the water block. Finally, if you mount it with the tubes going to the top like this, and either the pump is here or here, doesn't matter which, you're going to have problems unless the tubes are bent like this so that the pump is at a lower level than the top of the radiator. In that case, this pump is safe, but if the pump is here, it's not safe. However, again, just like before with the pump being inside the water block, if you have an accumulation of air happening here, eventually it's going to start causing problems even if the pump isn't here, because it's going to impede the flow of water through the whole loop. So you really have to pay attention to where you're going to mount the AIO versus where the pump is located in the AIO. Because if you choose an AIO and mount it in a position where you're going to ensure air buildup, it's not going to last a long time. And just think, if I put it here, where is the air probably going to get trapped? And if you think about it long enough, you'll figure it out, because the air goes up, water goes down, right? It's not a hard thing to understand as long as you take the time to think about it. And that is primarily what you need to understand when you're choosing a water cooler. Even if it's a custom built water cooling system, you still have to follow the same rules. Air goes up. Yeah. And so always look for the best possible combination for your case, in terms of size, in terms of the pump, in terms of the radiator, in terms of the fan, in terms of where the pump is located in the loop. And always remember, if you want your system to be even more powerful than the one you bought, so say you bought a $50 system that has a great pump in it and the radiator is spectacular, but the fans suck, which is often, unfortunately, with some brands, true, that they put inferior fans on them. Like this Pure Loop has got, well, for a the type of bearing that the fans have for that Pure Loop, they're very good bearings, but they're still not good compared to the top end bearings like ball bearings, fluid dynamic bearings, Noctua's SSO2 bearings, and some of the others are much, much better. You can have a lifespan with this, say the light wings and the dark, I think it's, what is this? Dark wings, or not dark wings, light wings and shadow wings, or I forget what it is. Anyways, if you aren't getting the Silent Wings Pro or Silent Wings from Be Quiet, if that's your choice, then you're getting that kind of bearing, and it has an expected lifespan of 80,000 hours, which is a lot until you look at the fact that there are AIOs with fans on them that can last 100 hours, 100,000, 200,000, up to, I think I've seen one that goes up to 500,000 hours. Or if you can't find an AIO that lasts that long, and hopefully the pump will also last longer than the fans, because if you're buying a pump that only lasts for 40,000 hours, you're going to end up with a radiator and fans, and you're not going to be able to use it because the pump will have broken first. So you always want to make sure the pump's high quality. You always want to make sure the radiator's high quality, and then make your system or your loop faster by swapping out the fans for the best, strongest fans you can afford. So high CFM, which is cubic feet per minute, and high millimeters of water, or MMAQ, MMH2O. Those so CFM measures the airflow, or in this case, water flow. No, it doesn't. I'm talking about fans. It measures the airflow of the fans, how much air is moving, and how much pressure it's applying to that air as it's moving it. So you could have a fan that has a CFM of 500, but the millimeters of water is only 1. Well, it's going to be a horrible thing to use on a radiator. It's not going to do any good. In fact, you're better off going back to the default fans that the AIO came with. But if you manage to find a fan that has, say, 10 millimeters of water and 50 CFMs, then you're looking at something that's really pretty good. Now, the higher you go on both of those numbers, it does tend to improve to a certain point. Now, keep in mind, one of the benefits of a water cooler, and there aren't a lot of benefits other than the fact that the best temperatures that can be achieved are through water cooling, but the best air coolers are right behind them in terms of the actual degrees of cooling that are achieved. The big difference is that this is much larger than any heatsink you're going to see on an air cooler, and as such, it's going to take longer for this thing to become what they call heat soaked, which means it's reached the capacity for heat that it can handle before it just can't suck any more out through here. And that means at that point, once it gets to the point where it's heat saturated or heat soaked, you're going to have reached the point of equilibrium. You're not going to experience any better performance than whatever your pump and fans and radiator allow for. And so that's why better fans can make a difference in terms of the performance. So you can save money with an air cooler or a water cooler by getting something that has good quality, cheap fans, and then swap the fans. All right. Well, that's it for me today. And the next video should be some videos on the temperatures I'm achieving with the AIO mounted in my computer in various positions. If there are any questions, please do put them in the comments, and I'll try to answer. Sorry, I had some soda and it's coming up. It's bubbling. And if you have any comments, do, as always, please keep it civil. I have low tolerance for people who are being jerks. And, you're going to either have your comment deleted or reported or you might be banned. And, I prefer not to do that to people. But, there are trolls all over the internet. And my solution to trolls is get rid of them. And since the only way I can get rid of them is by doing things like that, I do. All right. Thanks again, and have a great day.